Okay, here is the promised video on the bearing and direction, problem number 1. So we have a boy who is going for a walk, and he is going to start going at a bearing of 45 degrees, and he's going to walk for 5 kilometers. Okay, so whenever you have a bearing, you start with a north arrow, and then you take the angle, the bearing, to the north angle, to the north direction. So 45 degrees, a bearing of 45 degrees is you go clockwise 45 degrees from the north. So this is a bearing of 45 degrees. And then the length is going to be 5 kilometers. So let's say each unit here is 1 kilometer. I can actually make myself a little paper ruler, and I can mark off from the starting point, and I can go 1, 2, 3, 4, 5, make a little mark there. So I can actually kind of draw this to scale. So 45 degrees, of course, is just cutting straight across the diagonals there. So I can put that on there, and there's my 5 kilometers. So I'm trying my best to draw a very careful diagram so I get a good idea of what's going on. All right, so now the boy is right here, and now he's going to take a new bearing. So when you have a compass, and I wish I had one handy, but they're all in my classroom, I think. When you have a compass, the arrow points north. Okay, so the magnetic arrow always points north. That's why bearings are based on compass bearings, and the compass always points north. And then you figure out, well, which direction do I want to go? It's always going to be in relationship to that north arrow. So now he's going to go 120 degrees. So you turn clockwise 120 degrees, and he's going to be going in this direction now. So he started here, he walked 5 kilometers, and then he turned again with a bearing of 120. It's always relationship to the north because your compass always points north. And this time he's going to walk 8 kilometers. Okay, so I took my little paper ruler and I counted off 8 units. That's 8 units, and then I put it there. I didn't measure 120 exactly, so this is approximate, but it looks pretty good to me. And there is my 8 units, and then I drew it in. Okay, so 90 degrees, of course, would be if I just made a horizontal line here. So I would need another 30 degrees. So that looks okay. I could actually take out a protractor and measure it, but I'm not going to be that crazy. All right, so then he ends up here. Okay, so we'll call that point C. So he starts at point A, he walks, we'll call this point B, he walks 5 kilometers to point B, and then he walks 8 kilometers to point C. And then the question asks, where did I do my question? The question asks, find his distance and bearing from his starting point at the end of the walk. Okay, so the distance from here to here, how far is that going to be? So I could actually use my paper ruler to get a pretty good idea. If I'm starting there and I'm going here, I could actually take my paper ruler and I could get a general idea. It looks like 8, 9, 10, about 10 and a half is what I'm thinking my answer is probably going to be. But then I also have to get the bearing. And so the bearing is going to be from here down to here. How many degrees is that? So those are the 2 things I need to find. I need to find this distance, so I'll call it x. I need to find x kilometers, and I need to find the bearing. So I could do this using just geometry that we already know. I could figure out the angle in here, and I could use the law of cosines to find the side across from that angle, and I could use the law of sines to find these missing angles. Could totally do it that way. But we want to learn how to do it using vectors. Okay, so you could totally do this problem just using geometry. But if I were to add yet another compass bearing, if I was to keep moving them, it's going to be much easier to do this with vectors, because notice what we have here. He's going in this direction. So we have a magnitude and a direction. And then he's going in this direction. Again, I have a magnitude and a direction. So these are vectors. This is a vector, and this is a vector. So I want to write these in terms of vectors. I'm going to call this one vector u, and I'm going to call the 8 kilometer one, I'll call that vector v. Okay, because I can then do u plus v. I can add these together, and that will give me vector ac. Okay, so vector u plus vector v is going to give me from A to C, because see how these are head to tail? that would give me AC, vector AC. And then I could also find the magnitude of AC to get this length. Okay, so let's go ahead and let's change these into component form. So to change it into component form, I'm going to start just with this one right here with my vector U. So vector U, we said it's going like this. It's at a 45 degrees to the north. Here's my north. I know this is 45 degrees. And I need to find what is my X component and what is my Y component. Well, we know that the length here is 5. I'm going to erase that 45 degrees. It's kind of in my way now. We know that my hypotenuse here is 5. It has a length of 5. And because this is a 45 degree angle, I actually know that these are both going to be the same. So I could actually use the Pythagorean Theorem to find my X component and my Y component. But normally, you can't use that, the Pythagorean Theorem so much. You can only do that if this is a 45 degree or if it's another special right triangle, like a 30, 60, 90. So I'm going to go ahead and do this as if it was like some random number. Okay, so in order to find X, my X component, I can use SOHCAHTOA. SOHCAHTOA. So I have X is adjacent to the 45, and this is the hypotenuse. So I'm going to use cosine. So cosine of 45 is equal to adjacent over hypotenuse. And so I can solve for X. X is just going to be equal to 5 times the cosine of 45. And now I can do the same thing for the Y component. Okay, so I'm changing this vector into component form. So the Y component, well, that's going to be sine because it's opposite and hypotenuse. So sine of 45 is equal to Y over 5. And I can solve that for Y. Y is going to be equal to 5 times sine of 45. All right, so that is vector U. Vector U is equal to 5 cosine 45 and 5 sine 45. And I could change those to decimals. I could just put those into my calculator, but I'm going to wait on that for a minute. Okay, now I'm going to do vector V. So vector V, where should I do that? I'll do it up here. So vector V is this one. So I've got it starting at some point, doesn't matter where, and it's going this way for 8 units. Okay, and I know it's going that direction. So it's going 8. That's 8. And when we set up vectors, it's in relationship to the x-axis, right? So I want to know this angle right here. So this angle, well, we know that this from here to the horizontal is 90. So 90 plus what would give me 120? Well, that would be 30. So this angle has to be 30 degrees. So if I change this into component form, I've got, this is 8. Here's my X and here's my Y. Notice my Y is going to be negative. Just notice that, okay? I'm going to the right and then I'm going down. So when I solve for Y here, we're going to make sure we make that negative. Okay, so same thing that I just did for U, okay? This was all about vector U. I can do the same thing for vector V. So I am going to have, and I should have given myself more space. I should have started this up here. Darn it. All right, so to find X, I'm going to use cosine of 30 because X is adjacent to the 30 degrees. So I'm going to have cosine of 30 is equal to X over 8. So I get 8 cosine 30 is equal to X. By the way, you could use your unit circle to solve these problems. Look, 30 degrees, 45 degrees, these are all over the unit circle. But you can also use your calculator, it's fine. But if you want for a little extra challenge, use your unit circle to solve these. Okay, so that's the X, and then the Y, are you catching on? Are you catching on what's going on here? What's going to be the Y? It's just going to change from cosine to sine. Okay, so the Y, I could run through the whole thing, but hopefully you're seeing the pattern here. It's going to be 8 sine 30. So vector V is going to be equal to 8 cosine 30 is the X and 8 sine 30 is the Y. See this? See how you always get this pattern, okay? The X is the cosine and the Y is the sine. Oh, but I almost forgot. The Y is going to be negative because see, it's going down. So let's make that negative, make the y negative. All right, now I can just add these together. So I'm going to add them together. And so u plus v is going to give me my AC. So my AC is going to be equal to these added together. Now here's where I could grab my calculator and go ahead and just put these in. So I'm going to have 5 cosine 45 plus 8 cosine 30, and I get 10.46. Okay, that's my x component, and then my y component, 5 sine 45. Notice I'm closing my parentheses there, plus 8 sine 30, right? Yeah. Oh, it's negative. Oh, I almost forgot to put the negative. Let's go back and change that to a minus because it's a negative. And I get negative 0.464. Okay, and that makes sense. That makes sense. If you look at this vector right here, the x component is 10.46. So 10.46, and then negative 0.464, negative 0.464. So remember I said I wasn't sure I drew this angle all that great. So probably I drew it a little bit too low. Okay, it should have been a little higher up. But these numbers seem to kind of make sense for that vector. So these numbers make sense. Okay, so now I have these numbers, and now I need to find the distance. To find the distance, that's just the magnitude. So the magnitude of AC is going to be equal to the square root of 10.46 squared plus negative 0.464 squared. Put that into my calculator. So second function, square root of 10.46 squared plus, I'm going to ignore the negative because when I square it, the negative goes away, 0.464 squared, enter, and I get 10.47. 10.47, which would round off to 10.5 if I'm doing 3 significant figures. So 10.5 kilometers is the distance. And then to get the bearing, I could change this back into, a bearing and distance form by making a triangle. So I could do like, oh, what the heck, let's just go ahead and do it. Why not? Okay, so here it is. Here's my triangle. This is the 10.46. This is the 0.464. I'm trying to find this angle right here. Okay, so that angle, here's my right angle. To get this angle, call it theta, I'm going to have to use tangent of theta is equal to opposite over adjacent. So 0.464 over 10.46. I really should have used a bigger piece of paper for this. So I'm going to do inverse tan. So theta is going to be equal to tan to the negative 1 of this, 0.464 over 10.46. So inverse tan of, I have this in my calculator, right? So that one divided by that one. And the negative shouldn't matter. And I get 2.54. So my theta, this angle right here, theta is equal to 2.54. Sorry, it's such a mess. 2.54 is this right here. And now, though, to make it a bearing, remember a bearing is in relationship to due north. So I'm going to have to add that to my 90 degrees. So if I add that to my 90 degrees, I get my final answer that the bearing is 92.5 degrees because I'm rounding it to 3 sig figs, and the distance is 10.5 kilometers. And there it is. Okay, so there it is using vectors. But you also could have done it with the law of sines and the law of cosines. The thing about the vectors, though, is that there's this lovely little pattern that you're going to start getting used to when you have things in bearing in distance form, it's really pretty simple to change it to a component. And then once it's in component form, all you got to do is add them together to get the resultant vector. So it's really nice to be able to take something that's with a bearing and a magnitude and change it to component form, because then you can perform these simple algebraic operations on them. If you tried to do it without changing these to vectors, then you're going to have to deal with the law of sines and law of cosines, which is a bit more complicated. Okay, so that's it for my explanation. Oops, I gotta stop this video. There it is.